Good evening, good morning, depending on where you are. Welcome to Skill Me Up Expert Talk session, Azure Security Best Practices. My name is Karl Ots. I'm a cloud and cybersecurity expert, Azure MVP, and a regional director. Right now, I'm working at Swiss Re, a large Swiss financial sector organization, where I'm looking at our Azure security enterprise-wide. You can look me up at Twitter at Karl J. Ots. I mostly retweet and stalk different Azure announcements and news from the community. Today we have quite an action-packed session. We have almost a full day worth of material distilled into 45 minutes. So there's lots of opportunities to miss if you blink or if you sip a coffee. So feel free to take that coffee now. If you miss something, do go ahead and check the recordings in the Skill Me Up website. We're going to start by talking about access control in Azure, some of the best practices and considerations around there. Then we'll move over to compliance and cover specifically two key scenarios. We're going to cover access to data, data protection, and other data service related security considerations, best practices, and also a brief overview of application security across platform as a service, infrastructure as a service, and even container as a service. So let's get started. Very briefly, I hope you have already had the pleasure of going into deeper within the Azure role-based access control model. It's something that I feel a lot of organizations either don't understand enough, want to complicate this with existing materials or complicate with this with some edge case considerations. So I have a couple of more detailed scenarios here for your consideration. But all in all, the key parts of role-based access control are really the possibility of assigning the specific scope, Azure identity, user group, or a application, and finally the role. And really a couple of notes about the role-based access control assignment scope. Our assignment scopes are really inherited, which means that if I assign something on top of a subscription, it gets inherited to any resource groups and any resources that ever will be created inside that subscription. And the same applies with any different scopes as well. So you should really drive to minimize your broad subscription level scope assignments altogether and prefer the resource group assignment. There are some scenarios, such as creating Kubernetes clusters or setting subscription-wide settings, that do require a little bit different type of approach, but we do have ways of elevating privileges or putting that behind a controlled environment if needed. So here's an example of a quite typical environment in Azure. This is a resource group view specifically, as you can see, and you have different identities added as different roles into this scope. And we also see the inheritance. So let me walk you through this first. First up, we have the identity, which is assigned three different roles. This double face palming Karl here, over here, here, and here, we are using the same identity. Specifically into this scope, this resource group level, I have assigned contributor access into this or for this user. But as this is also the owner of this whole environment, I actually see that I'm the one who's actually been added in the management group level also as a management group contributor, so that I can actually create and modify management group assignments. And also, I'm a user access administrator, which means that I can perform operations that are typically considered owner type of operations across the whole management group. I can assign access, I can remove access, I can invite new people, and so forth. But I also have specific roles related to these scenarios. So this other Karl here, KA initials, this Karl actually has been assigned into this resource group as a storage blob data reader, and this is now a specific Azure data pane role-based access control role that gives me access to read any containers in the storage account blob and any blobs, any files within those containers. I can list, I can read, I can download the files. I don't need to get my hands onto the access keys as I can with the contributor. Here's a different look at the same part. Now, this time we have taken the liberty of not assigning these individual users access and have a little bit more sophisticated approach where we have role-based access control assignments done statically. So we have an Azure AD security group, storage demo contributors, storage demo blob readers, and storage demo user access control, user access administrators. And these are all Azure AD groups. Instead of having more decentralized view and more of those point-to-point Azure role-based access control assignments into individual users, I actually move away from RBAC assignments, and granting access as a storage demo blob reader is as simple as making the change into the group members in my Azure AD. This is quite nice because typically Azure AD is already established and synchronized with our existing environments, which means that we can rely on our existing identity and access management and specifically identity lifecycle policies that we have already in place. On Azure side, our access looks pretty much static once we have set all of this up initially. And finally, the third option will be to actually remove static assignments altogether, remove permanent access control, and move into this privileged identity management role. On that side, static or permanent role assignments, we will only have one application automatically generated by Microsoft, named MSPIM, short from Privileged Identity Management. And as you can see, it now has the user access administrator role, as I had earlier for my regular user as well. So this application can actually make those changes in the role-based access control, grant new users access, and remove them based on business rules. And instead of modifying everything, all access in our existing lifecycle system in our on-premises as memberships to groups, or instead of modifying them here natively in the Azure role-based access control, we actually use a separate privileged identity management portal, a separate application built by Microsoft to make those changes. So right now I've actually added under eligible roles. So I've created into the same storage demo role resource group scope, I've created instead of role assignments, I've created two role eligibility, I'm guessing assignments, role eligibility nesses, not a word. And similar to as previously, I have a user, I have a role, and I have a scope. But this time, everything is behind the workflow of business logic. I can set up rules that my access gets removed after a certain period. I can set up that there is renewal certification for this particular type of access. I can request or even I can require multi-factor authentication. I can also require business justification or someone actually to approve my requests for these roles. So this is a more sophisticated approach where we remove the permanent environments and permanent role-based access control assignments and only have or move away from that and actually manage all of our Azure access within the privileged identity management. This does have some licensing questions, and it's not perfect either in terms of setting up an automation, but this is definitely the best practice in terms of minimizing the privileged access in our Azure environments. So let's move on from that same assignment choices or assignment strategy into the specific scoping. And I mentioned earlier that there is this high privileged scope in itself called the subscription that has quite a wide inheritance and quite a wide approach here. So my personal example of a guideline will be that, or a recommendation will be that in your organizations you would clearly define what are the specific scopes and roles that are appropriate for any given stage of your development. For example, this is just an example table that I'm going to build up here. First, we have the owner in the resource group. This is quite high privilege. Again, the owner can has access to create and read and update and delete any resources, but can also do the same for access management. So they can assign access to this resource group. They can remove anyone's access, and based on your Azure AD configuration, they can also invite guests as well. So this is very high privilege, not so often recommended, but could be appropriate for our regular users in our Azure AD, but really should be provisioned in this high privilege account type, perhaps having different sets of credentials, perhaps having additional controls applied in our identity and access management. And this is quite appropriate role and scope when we are developing new services and we don't really know what's going to happen in the future. Most likely this environment where we have this that should not have any connection to our existing Azure or on-premises applications. Next up, we have the contributor in the resource group scope. The contributor can do almost anything. They can create, read, update, and delete any existing resources or of course, new ones in the resource group. But they cannot manage the access, and they cannot technically perform any role-based access control. They cannot perform any Microsoft authorization operations beyond the read operation. So of course they can go ahead and read who has access and which roles in this scope, but they cannot modify those. So a good rule of thumb or recommendation will be to again require to have local user account, not a B2B guest here. Maybe if there's a need for a partner to develop this, then they could be provisioned into our own Azure AD using the regular X account approach here. And this is really the appropriate role for partners developing new services. They're contributors. They can do what they need to in their respective scope, but they cannot go ahead and modify authorization or access control changes. And lastly, typically this is where this central governance or pre-analysis falls apart, because we don't always know upfront which types of services we are going to have. And we could approach this in two different ways. We could evolve this list of recommended roles and scopes. We could specify resource-specific roles. We could say that when it's a matter of a developer, then they need to have virtual machine contributor and perhaps network contributor roles, and that's it. We could talk about these resource-specific built-in Azure roles. One way to encompass the same effect would be to actually just say that for any individual resource assignment, they could get the contributor access. So again, for the virtual machine, if they have a contributor access, they can perform effectively the same operations as a virtual machine contributor could in that same scope, but they cannot create new resources. And this is very appropriate role when we already are in the ops phase. We already know what resources we have. We can even go ahead and assign those built-in resource-specific roles as well. And why not invite your users as B2B guests at this type of a scope as well? Okay, so let's switch gears and talk about compliance. Compliance is, of course, not the same thing as security, but in this approach, or in this time frame that we are talking about compliance, we really mean a way of enforcing and ensuring that our existing security controls are in fact implemented, and the possible freedom that we give our developers is not being overused, let's say. And on Azure side, we have one key service to enforce compliance, both for monitoring and for other reasons. We have a service called Azure Policy, and it really adds that extra glue, those extra missing functionality that we cannot do just by switching scopes and roles in the role-based access control, as we don't have, for example, deny assignment available for us in the regular RBAC model. So Azure Policy complements this access control, but we can also enforce any other type of control as well. We can go into very specific details that I'm going to show you just next. But at the bare minimum, without the enforcement, we can at least get the monitoring in place. We get a central view of reporting. This is the same technology that Microsoft uses for providing you the dashboards in Security Center, so that you'll know what your security goal is. You know, as an end user, from one single pane of glass, what is expected for you. And this is also, from a centralized point of view, a good place, or a tangible solution that you can deploy at scale as well. You only define your security desired state once as secure Azure policies, and then you can deploy that into management groups or subscriptions or any scopes that you would Azure role-based access control as well. So once you're authenticated using Azure Active Directory and you're authorized to perform certain resource provider actions, after that, your request is sent to the Azure Resource Manager, which is essentially the master API or the API manager for any Azure resource types. So before this is sent to the specific resource provider, we go through this authentication layer and the policy layer in the Azure Resource Manager. So we filter through the possible checks. Are there anything that is in effect in this scope that prevents you from taking this specific Azure Resource Manager action? And this applies anywhere where you use Azure. It can be Azure Portal, it can be a specific command line interface tool, it can be part of your code. Anywhere you use Azure, in the end, it gets translated into the REST APIs of Azure Resource Manager. And there we have the Azure AD authentication, we have role-based access control authorization, and finally we have the Azure Policy Engine checks, all of which you need to pass in order to get access to send your request into these resource providers. And I mentioned Azure Security Center is something that is able to take advantage of these policies. So here is an example of something called an Azure Security Center default policy. So this is actually just a view of me creating a new Azure subscription and enabling Security Center. And previously, there was only the score available for us based on the amount of services I'm using. There was no visibility. What is this rule set based on? By default, this is now something that I can go ahead and check. How is this built? You'll see there are different categories. For example, in the compute and apps category, we have 34 policies altogether. And you'll see I can actually go ahead and modify these default settings. If I'm happy with Microsoft, what Microsoft does for the default one, but maybe want to disable for, maybe I consider some of those too extensive or some of those as false positives. If I'm already accepting the risk on this, I can go ahead and remove those and change these policy initiative and go ahead into each particular policy that I'd like to disable or edit the changes here. Same thing applies if I build my whole custom policy initiative, and then this is something that I can enforce users not to edit eventually as well. This ensures that everything that we can see in our Azure Security Center is always relevant, and people don't have this assumption that, hey, this is just some default setting. This is not really something that we should focus on. They can't really hide behind that as well. I really recommend you to look at the CIS Azure Foundations benchmark. There's a 1.1 version available, and Microsoft is also implementing a lot of these CIS benchmarks also as policy initiatives in Security Center as well. It's not as comprehensive. There are some services that are still not covered, or some controls that are not covered for some services, and some of those are just a matter of time, but some of them actually require you to use something else than Azure policy as well. There's some settings that you can only check at runtime using custom solutions such as HSSK or Secure DevOps Kit for Azure. Sorry about that. There we go. So when we consider our own security policy, and now I don't mean specifically Azure security policy, the technical implementation, when we consider our security guidelines and policy in general, we can take a look at the CIS benchmark, for example, that covers almost 100 different controls across these key, let's say, vendor neutral categories or sections, which we can go ahead and then see the proposed recommendations defined in the CIS benchmark, a handy tool, but still a large, several hundreds of pages long document. We can implement those into specific recommendations that Microsoft called Azure Security Benchmarks. These are available in Azure documentation as well. Microsoft has mapped these into the CIS policies as well. Some of those require still, as I mentioned, some manual interference or some manual tooling, but otherwise, if you want to base your own security policies on a standard set that already has wide coverage, then I really recommend looking at this specific framework as well. So really some best practice here is that you should really go ahead and customize the Security Center default security policies. Even if you haven't fully agreed internally on all of your policies yet, it makes sense to remove some of those that perhaps use a previous service of Azure or are applicable only to you in some specific circumstances. Make the users trust the Security Center this way by removing anything that is blatantly not applicable. And really we have these compliance policies, such as one for CIS, we have one for PCI DSS, and we have other security policy initiatives that Microsoft has built and mapped against certain standards and put available for us. They are essentially the same view or same data set that you get from Azure Security Center anyway, so not all services are covered, but against that, Microsoft has done the heavy lifting of mapping those into security policies, and you'll get the nice view and even a PDF export on your status. If you use custom security policies, you're going to have the same logic and implement that in your own customer-specific security policy exports as well. All right, let's move over to data. So the first step in securing Azure most used data service, Azure SQL, I really recommend you to take advantage of the built-in integration with Azure Active Directory. This is also something that is apparent in a lot of those existing security frameworks and benchmarks, but just to demonstrate you the power here, you can add Azure Active Directory natively using a GUI or just just a single piece of property in your Azure Resource Manager template. You can set an object as the whole owner of the Azure SQL logical server. By default, you can only add one as the owner. So I recommend, of course, using an Azure Active Directory group for that, not just as an individual user. If you want to add any lower level access, if you want to use that Azure Active Directory identity and granular access within your SQL database, you can definitely do that. It's as simple as doing a T-SQL transaction as you would assign any other roles. You just need to, instead of a manual local user, you need to define the from external identity or from external provider property there. But keep in mind that if you want to audit the access there, you should monitor the Azure Active Directory group membership changes within the Azure SQL audit logs. They are by default not stored in the Azure AD signing logs there either. And of course, you can add some client-side configurations there as well. Well, Azure SQL provides a lot of specific features, such as the dynamic data masking, where we can do server-side masking of sensitive data based on a predefined format or a custom regex-like service. Perfectly fine as well. And also a key component to consider is definitely the firewall, where we can set up IP address or virtual network subnet-based firewall within Azure, or we can even remove any possibility for data exfiltration by setting up our own DNSs within Azure and connecting into Azure private link altogether. That means that all traffic in and out of this service will be in our control. Also, if you do any of this in the VNet level, then I definitely suggest that you have a look at your network monitoring within Azure as well, and add those network security group flow logs there too. And finally, there's also the data protection part. Azure SQL, of course, integrates natively with Azure Key Vault. By default, Microsoft rotates and manages the keys for encryption for us. They are 256-bit AES encrypted. If that's not enough for us, or we need to prove that we are handling the keys ourselves, we can go to the transparent data encryption settings in our logical server level of our SQL database and enable the bring your own key or customer managed key functionality there. Keep in mind that you need to use Azure Key Vault. Right now, there is no possibility to hold your own key or bring your own vault mechanism here in these native services. So on the data side, Azure SQL provides some services that are not available for all data topics in Azure, but Azure AD support and role-based access control on that side, virtual networking support and firewalls, and finally encryption in transit are all relevant features for any Azure data services that we might consider, be it storage, be it data lake, with other flavors of SQL, or even event mechanisms or event hubs that we might consider. And finally, we'll move over to our applications. Let's very briefly talk about infrastructure as a service, platform as a service, and container as a service security in Azure. First thing I'd like to point out is hopefully obvious for anyone considering security in the public cloud, that really by definition public cloud is a public environment. So if you give the power to your enterprise to create anything themselves, there's a high chance that you'll end up creating honeypots all over. Here's just one example of one server, Windows server, publicly available in Azure, fully patched, a new environment, available 24 hours just for honeypot purposes. And you'll see if I query the logs from Windows event logs from that Windows server and look for failed login attempts, the Windows event log ID with that particular event log ID, you'll see that I have over 3,000 different usernames that were targeted with failed login attempts. And if we have a look at these numbers per each type, we'll see that the key, of course, is to disable some of the default ones, such as administrator in different languages. But still, if you have a look at those non-conventional ones, like we have Aloha, test, and user here, they are still hundreds of failed login attempts for each of those accounts as well. And the list goes on. So over 24 hours, just one virtual machine available to the internet, just one mistake, and I already have over 3,000 different users attempted to be logged in. So this is available for us, most likely not as visible into our intrusion detection, and very susceptible to password spray type of attacks. So we should really protect public endpoints. So any public endpoint you manage in your Azure environment is a risk and should be really carefully reviewed. And that means for infrastructure as a service, it really means that you should apply, for example, the native security components, such as network security groups, just-in-time access for security center, which is a feature of dynamically changing those network security groups, similarly to the PIM, removing a lot of the footprint of permanent access. Or lastly, the Azure Bastion, which removes all network level access into your environment and creates an SSL tunnel over HTML5 in your Azure portal, creates an RDP connection into your virtual machine and displays that or renders that as a web page inside your Azure portal, meaning that you've already logged in using Azure Active Directory, meaning that you can put your existing network controls, such as requiring to join from a organization approved network, effectively inside our CorpNet. And similarly for securing platform as a service data components, as we discussed, we have the option to create firewalls for private we can have the option to create firewalls for virtual networks. We can have the option to open those up through service endpoints, and also finally control it fully using Azure Private Endpoints and Private Link as well. And securing platform as a service application layer should be done using centralized services such as Azure Active Directory. Whenever we have any application web application that needs to be logged in, really recommended to use the Azure AD. We have centralized access. We see failed logins. We can centrally audit who have access to this application. And also web application firewall, a managed WAF that performs very well compared to any existing third-party vendors that you might install and manage on your own, but also very well compared to those existing cloud vendors, and is based on the OWASP rule set, Apache ModSpark specifically, but is very well configured as default as well. Here's an example of the same thing that we looked at from the Azure SQL side. Here specifically, the UI is slightly different. For Azure Storage account, when we configure the firewall, we have these options for allowing access from trusted, quote unquote, trusted Microsoft services as well. We can also specifically allow or not allow also access to Azure Monitor as well. This is very similar to what you would have in other Azure data services, but specifically for public applications, when you have your Azure Storage account serving static web content for clients, then you cannot really grant them access. You cannot create an access list on the network level, and you cannot really grant them access in Azure AD either, because they are not your users to manage. At some point, you need to grant access to public content in storage account, and you secure that using this token-based approach. You have these master keys or account access keys that you use to sign shared access signature tokens, which are effectively tokens that we can generate per individual user or even per individual request. We should have a process of identifying anyone who requests them. We can revoke them. We can create time to live. And there's a whole pattern of valet key that you're expected to use with that. But specifically, SAS tokens compared to the access keys give us the possibility to limit possible actions, such as limit this access only to read or list. But what is not as often used, how I see it, is the possibility to also limit the network controls in terms of requiring HTTPS only enforcement, or also adding allowed IP addresses for this SAS token. So, for example, if you are authenticating your user and creating them an SAS token in order for them to fetch your binary data in your bulk storage, you can add time to live limitations for that SAS token, and you can also add network limitations using the allowed IP address per each shared access signature as well. And for your application logic, as I mentioned earlier, Azure Active Directory should not be used only for authenticating users, but also using managed identity to create Azure Active Directory identities for your Azure App Service and Function App and other services such as virtual machines as well. If you have a need for storing connection strings, you should store those in Key Vault and create a managed identity for your app service and grant access to that Key Vault in that Key Vault for that managed identity, effectively removing that extra layer of yet another connection string to connect to my secure connection string location. And just one specific part there to add, by default, both the remote debugging and publish profile, publishing from Visual Studio and debugging from Visual Studio are enabled on app services. You should definitely have a look at enforcing the removing of those at scale as well. It's effectively a setting in app service. It's something that you can enable or disable as a policy, or better yet, remove it from your ARM templates as well. Okay, and finally then we have container as a service. So here's a brief overview of different considerations we have in terms of network and access control for a web application that will be hosted in Azure Kubernetes service. First of all, we need to protect the end user access somehow. We can add in the application logic Azure Active Directory as the authentication mechanism there. We can control access using different network controls. But we still need to provide access to our DevOps engineers, our developers, maybe even our other administrators there as well. So on the other hand, the users need to access the services running in our Kubernetes cluster, and our developers need to access the Kubernetes control plane. And the Kubernetes cluster itself, or more or less the applications, the services running in the Kubernetes cluster, they also need to be able to access our other Azure services, quite typically data services like Azure SQL database. So considering those requirements, we might build something like this. We might expose our Kubernetes application as a service. We might have an in-cluster ingress controller for that, quite typical. And from Azure point of view, that would look like us having effectively a public IP address behind a load balancer sitting in our managed environment, and controlling access to that load balancer and effectively that application then becomes our primary concern. From network perspective, as Kubernetes is just a series of infrastructure as service components, it is effectively sitting in a virtual network subnet, which we can configure access in Azure SQL database, as we discussed earlier on the firewalls and service endpoints, which means that we can actually restrict access from public and also allow the access from this cluster. That's fine. For admins, we have the same VPN options that we have usually. We can consider SSH as an additional control there as well. But how do we protect this part here, the application, a user connecting to the application here? Well, that's where the web application firewall comes in. And instead of opening the specific subnet for Azure Kubernetes service up with a public IP address, we can actually put in an Azure application gateway, turn that on as web application firewall. We can use this separately from Kubernetes, or we can actually integrate more tightly so that the WAF itself actually is the Kubernetes ingress controller altogether. So when we deploy a service within Azure, it automatically listens to the WAF. We don't need to add any pods to act as ingress controllers there ourselves. And then a quick laundry list of AKS best practices here. In the end, from Azure access control perspective, the part that we need to manage is this access to the AKS resource providers list cluster admin credential action. This is something that's available by default for a contributor. So that's something that we specifically need to either block using a custom policy. We'll need to work our way around that using in our role-based access control assignments. But this is really this high privileged action that we should really at least audit and monitor in our vulnerability assignments as well. Instead of that, we should add, instead of everyone getting this cluster admin credentials per request on their own, we should implement Azure Active Directory authentication within the AKS cluster. And on top of that, we should bind those into in-cluster appropriate roles as well. Ingress control, of course, for any type of secrets, just like with platform as a service or infrastructure as a service, we should store those secrets in Key Vault, access those using managed identities, either for the whole Kubernetes cluster, for each individual node, or even per each pod. All of those require a little bit different way of creating and operating those managed identities. Containers as a service are nice. They're portable. There's existing knowledge available, but it does require existing knowledge because there's more to operate compared to the serverless components. And if you share your clusters to really get the benefits of this small footprint of an application, then you should consider cross-pod networking policies and maybe pod identities to create identities in Azure AD for your apps as well. And that's it. We covered Azure Access Control in more details, different strategies on that. We covered a bit of the approach on the compliance, and we covered different Azure data plane configurations, access control, network control, additional features that are available in Azure only. And we covered different operating models, infrastructure as a service, platform as a service, and container as a service in Azure applications. That's really, thanks for listening to this Azure security best practices. Next session is next section is top 10 Azure security fails and how to avoid them on September the 2nd. If you have any questions, please feel free to drop those over here in the chat. I'll be hanging out here to answer any of your questions. And if you want to rewatch this, this is available in a couple of days in the Skill Me Up platform. And you can always reach me out over in Twitter at Karl G. Ots. Thank you very much.